and welcome to Fractions 4. Today we will be looking at recognising and showing using diagrams equivalent fractions with small denominators. Okay, so these are denominators that are less than 10. We should know by now that a denominator is the bottom number in a fraction. To work towards this objective, we need to know what equivalent means, what an equivalent fraction is, and how we can show equivalent fractions. Equivalent means that something has the same value as something else, so it's worth the same. And the equal sign means equivalent, it means the same as. Some people think that it means the answer is, but that is incorrect. Equals simply just means is equivalent to, is the same as, has the same value. So if we look at 2 add 2 equals 4, we're saying that 2 add 2, it has the same value as the number 4, which of course it does. And you could say 2 add 2 equals 3 add 1, because it does. Both of them equal 4. Both of them have the same value. They are equivalent statements. And we are looking at equivalent fractions, so fractions that have the same value as each other. Here is a fractions wall. And we can see here that we've got our whole at the top, our 1, and we have halves, thirds, quarters, fifths, sixths, sevenths and eighths. Obviously you could keep going, getting smaller and smaller, but for the purposes of this lesson, eighths is probably about as far as we want to go. Eighths and ninths, we don't want to go to a 2-digit denominator yet. So if you have a look at how the lines match up when you look down this fractions wall, you'll see that on quite a few, the lines are at the same level as each other. So here you can see this line between the two halves matches up with this line in the quarters, and this line in the sixths, and this line in the eighths. And if I were to take a pen and draw that line down here, you could see quite clearly that this half here, shade this half, one half here, is equivalent to or the same as 2 quarters, 1, 2 quarters there, or 3/6, 1, 2, 3/6, or 4/8, 1, 2, 3, 4. So these are all equivalent fractions. So a half is the same as 2 quarters and is also the same as 3/6 and 4/8. So all of those fractions are equivalent to a half. They're all the same as a half. And you can do this, that's not the only equivalent fraction. If you have a look down the thirds column, so this third here, if we just keep this line going straight down, you'll see that this third here is equivalent to 2/6, because it's the same size bar, they have the same value. If I had 2/6 of a piece of cake, I would have had the same amount as if I'd had a third of a cake. We're just going to have another look at fractions using DP Primary. And unfortunately, I have checked, this is not available for children to access. This is a teacher tool. I'm not sure why that is, but if we take a half and we'll make this thirds, we'll make this quarters, and we'll make this fifths, and we can make this sixths. There we go. So we can see that a sixth is smaller than a half, because if you divided something into 6 pieces, the pieces will be smaller than if you only divided it into 2 pieces. But let's see if we can find equivalent fractions. So for my thirds, let's add a fraction, or add, we now have 2/3, but this is larger than a half. So this can only be 1/3 or 2/3, but neither are equivalent to a half, neither are the same. So I'm just going to move this out of the way. Let's look at quarters. Oh, look at that. 2 quarters is the same as 1/2. They are equivalent fractions. Now, move this up. Ooh. Let's have a look at fifths. 2/5 is too small. 3/5 is too large. So I cannot find an equivalent fraction with a denominator of 5 for 1/2. Move this one down. And then let's look at sixths. 2/6 is too small. 3/6 is just right. So you've got 2 quarters, 1/2 and 3/6 there are equivalent fractions. And if you're looking for, say, fractions of a third, I can get a third there. And you'll see that 2/6 are the same in value. They are equivalent fractions. Okay, so hopefully that's also exemplified it a bit further for you. So, a question you might be asked to answer. Draw a diagram to show a fraction that is equivalent to a third. Now, the first thing I want to do is show a third as a fraction. Fairly easy to do. We've been looking at this so far already, so forgive the wobbly lines. Obviously, you would use a ruler. I can't really do that on my laptop, so I'm just going to draw my lines here. They should be equal. They're not quite, but we're going to pretend that they are. So I've divided it into thirds, if I had divided it into 3 equal pieces. And I need to shade one of those thirds, because I've got 1/3. There we are. Now, if I were to split it into smaller equal pieces, and again, they still have to be equal, like this. So I've now got 6 pieces. I've split into sixths now. And I can do the same on here. And we can see that my 1/3 here is the same as 2 of these sixths. So I've shown using a diagram that 1/3 is the same as 2/6. And if I wanted to, I could do it a different way. So I could, if I erase this one, if I took my third, divided my square into thirds, whoops, sort of, wonky thirds, and then divided those even smaller to make ninths, because I've got 9 pieces, and again pretend these pieces are equal, I would have to colour 3 of these ninths to take up the same amount of space as my third. So I could also say that 1/3 is the same as 3/9. Okay, so effectively what you do is you draw the fraction that you've been asked to show an equivalent to, so here it was a third, and then use lines to break it up into smaller equal pieces and work out how many of those equal pieces would be equivalent. So here I've said that 1/3 is equivalent to 3/9. Moving on, we want to draw a diagram to show that a fraction that is equivalent to a half. So I'd like you to have a go at this, pen and paper, a ruler if you've got one, don't worry if you haven't, but draw a square, divide it into half, shade a half, and then draw another square and think about how you could split that shape even further into more equal pieces to work out your equivalent fraction. Pause the video, resume it when you're ready. So I might split it down the middle. That's a really wonky one, but anyway. So there's my half. And if I were to split it in half and then split it in half again, I'd find quarters. And to take up the same amount of space, I would need to shade 2 of the quarters. So I've got 2 quarters is equivalent to 1/2. And you could have come up with any number. You could have come up with 4/8, you could have come up with 3/6, you could have come up with 5/10. Basically any number where the denominator is twice the numerator, and that answer would be correct. So well done if you've got something like that. So let's complete the statement. 1/3 equals so many sixths equals so many ninths. So again, we're going to just draw our third here, and I want to make sixths over here, so I can do it by thirds and then just divide it in half again. I've got 1, 2, and you can see there's 2/6 there, making a third. And what about ninths? Well, I can divide the circle into thirds. Bars are often easier. I would usually advise you to do a bar, but it is possible to do it with a circle. So divide into thirds. And then for the ninths, I'm going to divide each third into 3. So there should be 9, should be equal, but they're not, but pretend they are, 9 equal pieces. And I want one of these thirds. And how many ninths is that? Well, that's 1, 2, 3 ninths, making roughly the same amount. And there's my equivalent fractions. Oh, now, just before we finish, so we need to recognise and show using diagrams equivalent fractions with small denominators. So we should know what equivalent means. It means the same value as something else. We know that an equivalent fraction has the same value, or a pair of equivalent fractions have the same value as each other. We know that we can show an equivalent fraction by drawing the fractions out and showing that they are the same size. Yeah, I hope this has been helpful. Have a lovely summer break, everyone, and Medway will see you again in September.